Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And as the title of the video suggests, today we are going to write a C++ program to implement postfix to infix expression conversion using a stack data structure. Yes, this is the practical side of postfix to infix using stack data structure, and this is sort of like the part 2. In part 1 we discussed the working, the rules as well as the pseudocode. And we also took an example, we dry run that pseudocode onto that example to convert a postfix expression to a infix expression using stack data structure. So that's where we actually understood step by step every detail. So if you've missed that, if you don't know how the actual working goes, please watch that. But if you're just here for the program, for the implementation, for the practical side, this video is just for you. Make sure you watch it till the end. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so as you can see on the screen, I've already opened up my Dev C++ IDE. I've typed in some code. I would highly recommend that you guys pause this video, type this out yourself for the first time for the best practice. If you're an absolute beginner, this is really important. And to give you a quick overview, we are going to write a code which is basically going to take a postfix expression. So in the int main, you can see we are saying string infix and postfix. We are creating two string variables. This is C++ style string and not the C style string. If you don't know the difference, I have a separate video which explains the difference. Then we say enter a postfix expression. So we take the postfix expression from the user. We print that postfix expression as it is. Later we say infix is equal to, we call this user defined function postfix to infix, which we still have to create, and we pass this postfix string as argument. This postfix string is passed into the postfix to infix function, which will return a infix string from this postfix string. And then at the end we will print that out as well. Okay, so this is what the int main code looks like. On the top, you can see I have the basic hash include IOStream, which does the input output functionality, but I also have this hash include stack, which is gonna include a stack data structure for us, which is predefined in C++ library in the STL library basically. And if you don't know what is STL, it is the standard template library which is provided by C++ for us, which has certain standard data structures, which has certain standard algorithms and functions which we can directly use in our code instead of writing our own stack code, right? Because today's program's motto or goal is to understand the conversion and not create a stack on ourselves. If you don't know how to make your own stack data structure, I have a separate tutorial for that. Okay. So moving on now, let's actually start with creating this custom user defined function. So I'm just going to copy it and let's go above int main. It is going to return a string which is going to be stored in this infix string, right? So the return type has to be string. I'm going to paste the name, and of course it is also going to accept a string variable. So I'm going to say string postfix. This is the argument. Now on the right hand side, I have displayed the pseudocode which we actually dry run in the previous tutorial, which we understood line by line in the previous tutorial. So we'll go according to this pseudocode, and in the pseudocode the very first step is to create a stack data structure. So let's do that. So since we've included this stack header file, so we've included all the functionality related to a standard stack which comes from the STL library. STL stands for standard template library. So we can create a stack object like this saying stack, and this stack is gonna store string variables inside it. Okay. Now if you remember, for the code of infix to postfix, we had created a stack which was storing character variables. Now this stack is going to store string variables. Okay, so there is a difference. So this is how you create a stack in C++ programming. If you're using any other general purpose programming, the pseudocode is obviously going to be the same, but the syntax will change. So for example, if you're using Java or JavaScript or any other general purpose programming language, things will change in terms of syntax, not the pseudocode. Okay, so yeah, this is step number 1. Step number 2 is a for loop which will iterate from 0 till the entire postfix expression's length. So string postfix will have certain length, right, depending upon what postfix expression we enter. So we have to iterate throughout that expression. So we will use a for loop. We will say for int I equals to 0, I less than postfix dot length. So since postfix is an object of string class, So this is C++ style string, right? So it is a object basically. It has some inbuilt functions which will give us the length of this postfix string. So we will go till I less than postfix.length and we will say I++. Okay. So this is that for loop. Now inside this for loop, if you see the pseudocode, we have two main conditions for two different types of symbols which will be present in the postfix expression. Now in the postfix expression, we will either have operands which would look like A, B and those variables, or we can have sub expressions as operands as well. And the second type of symbols that we will come across is the operators, which is plus, minus, divide by, multiplication and raise to, right? So these are the only two different types of symbols that we will come across, and that's why we have two conditions. We will have if. The first condition is for if postfix of I is an operand. Now remember, according to our pseudocode, if you can see, in step number 2.1 we are saying if postfix of I is an operand, we will go inside the if block, and in 2.1.1 we say stack.push this operand, right? So we have to push operands into the stack. In infix to postfix, that is the reverse process, we were pushing operators into the stack. Over here we are pushing operands. Okay. So how do we figure out whether the postfix of I, that is the character that we are currently scanning in the postfix string, is a operand or not? For that we will write a separate user defined function which will be of boolean return type, which will either return true or false depending upon whether the character is a operand or not. So we will say is bool is operand. In this obviously we will pass a character, right? And now to check whether this character is an operand or not, we are simply gonna check between A to Z in small caps and A to Z in large caps. So the condition programmatically will look something like this. We will say if this character C that we are passing is small a, and if it is between or if it is less than or equal to Z, which means that it is in the range of A to Z, because ASCII values of alphabet A to Z are consecutive to each other. So they are just next to each other in one particular order. Similarly, we have an OR in between. So if I put it in one line, we have an OR clause and we say if C is greater than equal to capital A and C is less than equal to capital Z. So in that case we say return true because it would be an operand, and in the else part we say return false because it will not be an operand. Okay, makes sense? Pretty basic function. You can just pause the screen and type it out. I'm obviously going to be sharing this entire code with all of you guys. So on our official website you'll see the article which will discuss the theory, the rules, the pseudocode as well as the entire C++ code. But I highly recommend that you type this code yourself for the first time at least. And moving on, now we can use this user defined function inside our postfix to infix function. Over here we will say if, and then we will say is operand, and we will pass postfix of I. So the symbol that we are scanning currently in the postfix string can be passed as a character in this function. It would be passed, and depending upon whether it is belonging in the range of A to Z in small caps or A to Z in large caps, it will return true, which will mean that it is an operand. And if it is an operand, remember what we have to do. In 2.1.1 it is saying s.push, that is we have to push it onto the stack. So to push it onto the stack we have two lines of code over here, not single line like the pseudocode, because obviously pseudocode is not exactly the syntax. So this is how the syntax looks like. We create a string OP, which is operand basically. Then we call the constructor of this string class, and we have two arguments. The first argument is a number 1, I'll explain to you what it is, and the second argument is postfix of I, which is basically the character, right, that we are scanning. So why do we have to use this? Now this syntax basically what it does is it takes this character at this postfix of I position and it makes one copy of it. So this one represents how many copies you want in this string OP, and then it puts it into this OP string, but it also changes the data type of postfix of I, which is gonna be a character, to a proper string data type. Okay, so string data type is not equal to a character data type, so we have to convert it, and hence we have to use this syntax. If we didn't use this syntax and if you directly say string OP is equal to postfix of I, this will throw us an error. Okay, so if I try to save this and let's see if I try to compile and we get that error. So there you go, you can see we are getting this error. If I show you that error, you can see the error is at line 26, which is basically this line. and the error saying invalid conversion from char to const char star. Okay, so that's why don't use this syntax, use this syntax if you're using any other general purpose programming language. The syntax obviously is gonna be different in your case, but for C++, this is how you go about it. This first argument states how many copies of this second argument you want in the OP string, and this constructor basically takes this character, makes one copy and puts it in the string OP with the new data type of string. Okay, and then obviously the second argument is s.push, because we've created the stack over here at the top. Before the for loop, we just have to push this OP onto the stack. Simple enough. Now in the else part, we don't obviously have to check in the else part whether it is an operator. So if it is not an operand, the only other type of symbol in the postfix expression is gonna be an operator. So we directly use else, and in else part we have like 6 instructions over here, you can see. So let's go line by line. The first line says create op1 and store s.top in it. So the way we go about it is we say string op1, we say s.top, then we have to pop the top of the stack, we say s.pop. This will basically remove it off because the top of the stack is now stored in op1. So we want to access the next element in the stack. So we have to first pop the top of the stack, right? So that's why s.pop. Then just copy this again, hit enter and paste. We say op2 again, which says s.top, and then again s.pop. So 2 elements from the top of the stack are in op1 and op2, and we've removed them from the stack, but they are stored in these 2 strings. Now step number 2.2.5 says we have to create one more string exp, which is gonna have opening and closing brackets. Inside that we will append op2 plus the postfix of I, which is gonna be an operator, plus op1, and that will be a sub infix expression formed from those postfix values in the stack. So this we've clearly discussed in the previous tutorial. If you are confused, do watch that. And then 2.2.6 we say s.push this expression. So in coding, if instead of creating this extra variable, what we can do, we can club these 2 instructions, 2.2.5 and 2.2.6 together, and we can say s.push, directly add this opening bracket, then we say plus, we say op2, then we say plus postfix of I, then we say plus op1, and then we say plus again this closing bracket. So plus is basically here used to append all these elements together and then directly push it onto the stack. So we've combined those 2 instructions in one instruction so that we don't waste extra space creating that extra exp string variable. So that is pretty much about it for the else part. After the else part, obviously the for loop ends. So this is where the for loop ends. Let me hit enter. And only one last instruction is left in the pseudocode as well, which we have to return the top of the stack, right? Because you can see our custom function postfix to infix has a return type of string. So it has to return something. So we will say return s.top. In the pseudocode also you can see after the loop, after the end loop statement, we have return s.top. And this is pretty much it. This is pretty much our short and sweet postfix to infix custom user defined function, which takes a postfix string, converts it to infix and returns it. And this we will use in the main function obviously. This is where we are calling it. So let's see, our program is pretty much ready. Let's try to save it and compile and run. I hope we don't get any error. Okay, our program is running fine. Let's enter the same postfix expression that we dry run in the previous tutorial. So this was the entire postfix expression. Let me hit enter, and this is the postfix expression, and over here is our proper infix expression, and this is accurate. You can cross verify it by manually converting this to infix. We've already discussed how to manually convert postfix to infix and infix to postfix, both processes. Then you can cross check it with this one. And there are a lot of brackets over here because in infix we require brackets to determine which part of the expression happens first or is evaluated first. That's why we're using brackets. Okay, so this means our code is working perfectly fine. Let's try to do it one more time with a basic example. I'm gonna say AB star plus. Now this is a postfix format. What would be the infix format to this? Okay, there has to be C also. ABC star plus. The infix format should be A plus B star C, right? And obviously B star C should happen first, so it should have brackets. Let's hit enter, and there you go. You can see A plus B star C, and B star C has extra set of brackets, which means our program is working perfectly fine. Okay, so this was the practical side of postfix to infix conversion using stack data structure. We've successfully written a C++ program, and I hope you understood this entire program. If you like this video, please give it a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and I'll see you guys in the next video. Peace.